Hello everyone. For the next example, we'll be analyzing the fire hydrants dataset. This is a real life dataset from the city of Madison. Real life datasets are often problematic. You're going to have to deal with issues like inconsistent data entries, missing data entries, and so on. We're going to run into some of these problems as we proceed with our analysis. We're going to shift our focus back to bar plots. In today's lecture, I'll be covering simple examples of bar plots while analyzing the fire hydrants dataset, but we are going to continue our analysis at the beginning of plotting for lecture, where I'll introduce you to advanced bar plot options. Let's go ahead and read fire underscore hydrants.csv files data into a pandas data frame by using read underscore csv function. I'm going to take a peek at the data frame df. Notice that we have a lot of columns in this particular data set. Whenever you have a data set which contains too many columns, it's often helpful to get a list of the column names. You can obtain that information by saying df.columns. That's going to get you a list of all the column names. We want to be able to create a bar plot in order to visualize the colors of fire hydrants. The nozzle color column gives us the information about fire hydrant colors. Recall that you can extract a specific column from a data frame simply by saying df of column name, and that's going to return a series of that particular column values. Looks like we have a lot of fire hydrants which have blue color. Some of the entries are also missing. What we want to be able to do in order to generate this bar plot is to count up the values of the fire hydrants which have the same color. Recall that whenever you have a series, you can use the value underscore counts function, which counts up the count corresponding to each of the unique value entry within the series. Value underscore counts function returns a new series which has the index of the unique color values, and the values are going to be the computed counts. The series itself is going to be sorted based on descending order of the computed count over here. We can create a bar plot from this series that is being returned by value underscore counts function. So I can simply say dot plot dot bar. Recall that whenever you have a series, the syntax for creating a bar plot is series dot plot dot bar. Something is wrong with this particular plot, correct? Go ahead and pause the lecture video here and take a look at this plot and write a comment on the comment section stating what do you think is wrong with this particular plot. If you were thinking that there are redundant bars for the same color, then you had the correct answer. Looks like there are 3 different bars for blue color and 3 different bars for green color, correct? This is happening because we are dealing with a real life data set. We will have to deal with inconsistent data entries. In order to do that, we are going to clean up all of those values and convert all of the color values into upper cases. Recall that you can use the str.upper method call on a series. You can just say df of nozzle color dot str dot upper, and that's going to convert all of the color values to upper cases. This line is kind of getting really long, so I'm going to split that into 2 lines. I'm going to capture the cleaned up color values into clean underscore df, and then I'm going to say clean underscore df dot value underscore counts dot plot dot bar. Now value underscore counts function will count all of the blue color hydrants together. This plot looks so much better. Let's capture the axis subplot object, which is going to be the return value of the plot function. And let's go ahead and set y-axis label. I'm going to set the label as fire hydrant count over here. For the sake of example, I'm going to show you how you can set the colors for each of these bars corresponding to the color names for that particular fire hydrant. I would recommend you not to use the same part of your dataset to represent two different aspects of your plot. We have already represented the x-axis tick labels using the colors. So coloring the bars would be redundant, but I still want to show you how you can set those colors. You can pass argument to the color parameter, which is going to be a parameter in the plot bar function. This particular parameter takes as argument list of color values, one value corresponding to each bar. So I'm going to say B for the first bar, G for the second bar, dark orange for the third bar, R for the fourth bar, and for white I'm going to say 0.5. Not that we can see the white bar anyway, but you cannot display white on top of white background. And for the last one, I'm going to assume it's a cyan color, but I have no idea whether that's a valid data entry or not. Let's go ahead and proceed with the next example. I'm going to leave a note saying this is not recommended to do. The next example is asking us to create bar plot to visualize style of fire hydrants. We are going to do cleanup of the style just like we did a cleanup of the colors. I'm going to say df of style, and then I'm going to convert that into upper cases, and I'm also going to say count up all the values for me. Let me capture this particular data frame into a variable called styles underscore counts, and let's take a look at styles underscore counts dot plot dot bar over here. Alright, looks like we have way more styles than colors for the fire hydrants. This particular plot is an example of what is called as long tail plot. What exactly does that mean is that your initial few bars have a lot of count values, whereas majority of the tail for this particular plot has very few count values, correct? Whenever you have a long tail plot, it's often helpful to combine the long tail all together into a single bar which represents the other style of fire hydrants. Recall that we went through similar example while analyzing bus.db dataset. We are going to use series slicing in order to generate the updated version of this plot. Let me go ahead and copy paste these two lines of code over here. Instead of directly doing the plot, let's say that we want to extract the top 12 bars into a separate series over here. I'm going to do that by saying give me style underscore counts dot iloc. What I want here is a slice, so I'll have to say start colon end. My start is simply going to be 0, so I'm not going to mention that, and my end is going to be 12 because end is exclusive. Let's go ahead and take a look at this particular series. Looks like these are the top 12 fire hydrant styles. Let me capture this into a variable called top 12. We also want to be able to deal with this long tail over here, right? What do we want to do with it? We want to sum up all of those values. We can extract the rest of the data over here by simply saying 12 colon and not mentioning the end. That's going to get us all the entries from 12 until the last entry. What we want to do with that is we want to be able to sum those up, correct? Once we get this value, we can add this particular computation as an entry in the top 12 series. So I'm simply going to say top 12 of other equal to this value. Recall that you can add a new entry into your series just like you can say dictionary of key equal to new value. You can say series of index equal to the corresponding new value. Let's go ahead and display this particular bar plot. So I'm going to say top 12 dot plot dot bar, and let's capture the return value into a variable called ax. Then we are going to set ax dot set underscore y label with fire hydrant count. Right. That will be the plot for bar plot for visualizing various top 12 style counts, and looks like the other column is still less significant when compared to the top 12 styles for the fire hydrants. I'll wrap up this lecture video here. That will be it for plotting 3 lecture. As I mentioned, we'll be continuing this example at the beginning of plotting 4 lecture.